Hello. I started using this arm robotic kit. Um, then I got a problem here. Um, the right axis of the x-axis of the joystick was not working for me, so it wasn't giving me the correct output. So I decided to control it with my computer. So currently this arm is like connected to the power from this here. So the power at least should be 2 amps. I guess I was using 1.2 amp 5 volt power adapter, and it wasn't enough, so it couldn't move the arms easily, and then it was getting stuck at some position, and also it was the servos was heating up, and that was, I guess, dangerous. So here it's connected to the power, and then here it's connected to my USB to my computer. Yeah, so let me change the display to show you some stuff. So this is the code that is running on the BBC BBC microbit board. Actually, it's pretty cool that you can write a Python on it. I haven't seen any embedded processor that you could write Python. That was cool. Yeah, so basically the code is just initializing the pins. So to run the servos, unfortunately, you need to turn off the display because one of the pins is one of the pin for the servo is shared with the display, that these LED matrix here. So you have to turn it off to use it with this setup. And then I'm just setting up the pins. So the pin 16 is for gripper. These pins, the stuff is defined in the Python in microbit module. So that's pretty cool. And then I'm just setting all the servos to have the analog period microseconds for like 20,000 microseconds. So it's like 20 milliseconds according to the data sheet. So this is the data sheet that's expecting a signal to have like 20 milliseconds of period for PWM. I will share the links to these in the review. And then also I just set some values, some like 0. And also I set the UART communication to the 115,200 baud rate. And then the rest is just like parsing the string that is coming from the baud rate. So it's expecting a string of like this coming from the UART, sorry. So it's expecting a string like this from the UART. So it's starting with S and ending E, and it's just 4 values for each servo. So it with the same order of here, right, left, base, gripper. And after it receives that, it just applies that. So like here, update servo, it just iterate over the list and just say iterate over the list of the servos and just write the servo values to it. So this servo value is it's using write analog. So according to the MicroPython documentation here, so it says use write analog for the outputting PWM signals. So let me zoom in. Yeah. So when it's 0, it means the signal is completely off, and it's just 123 is just 100%, so it's completely full. So we have to map the 0 to 123 to something like these angles. So the servo is expecting through only 1 to 2 milliseconds of duty cycle. So that's it from the embedded processor side. So I'm not calibrating here. I'm just saying that I'm calibrating on the computer side. So on the computer side, I'm using Jupyter Notebook. So to control this, so the first step, let me restart the Jupyter Notebook starting from 0. So I'm importing some widgets, and also most importantly is just this serial. Yeah. So this serial package is just responsible for communicating through the UART and the USB through the robotic kit. So here I just wrote a class that just creates some widgets and communicate through the serial, and so through this class we try to find out some stuff. Like for now, I just said the servo maximum value we can send is just 125 and the minimum is 40. This is a bit wider range of the allowed values, but we start with this and we put the yeah. So let me run this. Yeah, I run that and then I just create an object. So when I create an object of that, it just creates me 4 sliders, each one for each servo. So if I change it, it just moves. So I have to hold it. The problem is that the robot, it doesn't stick to the bed because, yeah, I don't know. And this is the wooden bed. So yeah. So through this, I need to find out a few values to map the degree angles to the servo value. So I want to say, okay, if I want like 10 degrees, it's just 10 degrees from the above, and this arm is just like degrees from here, angles from there. So here I can just send some values to this to the kit, and then see what is the maximum values I can send. So I can just click here, and then also I can just move it with the keyboard. See, okay, where is the last position that it can go, and I write that as a kind of a maximum. This table is just, I wrote it for my setup. So I find out, like, for the right, the maximum value of the servo, which is like 121. So I can maybe probably go a bit further so it can move. Actually, it's not 121 now, but it's okay. So if you send more than enough, so it gets stuck, and probably the servos are getting hot. Sometimes if you see it doesn't come up, it's a bit weak. The servos are a bit weak. Yeah. So through this, I need to find out like minimum value for each servo, the maximum value, and I want to decide like a value for the 0 degrees. I want to decide, okay, for example, I want here, for example, 0 when it is completely upward, and for this, I want to say, okay, the place that is completely horizontal, I want to say it's 0 degree. So I just say, for example, for the right one, 73.0, and for the left one, let's say 82 is 0, which is like it's completely horizontal. But these are like, I just did it by eye, so there's no measurement. And also I need the minimum degree, so I want to say, okay, what is the minimum angle that it can go in degrees? So for example, I just put this in the minimum value, which was 46, and then measured it roughly with some tools. So for me, minimum was like -45, -60, and these sort of stuff. This is showing the angle that it's this is showing the string that is being sent to the UVC microbit. So yeah, this is the, you see, for example, right now it's not symmetric. From the range is not symmetric, really, because of like when we were mounting the servo pad, servo like arm, it can cause some errors there, but still functional. Yeah. So when I got these values, first I can close the serial. Okay. When I got these values, the minimum, maximum, the minimum degree, and the value for the 0 for the servo, I will put them here. And this is a class just to control the robot via the Jupyter Notebook. So and just run this. So here I got the values in degrees now, and it's pretty cool actually, right? So I can control it right now with these sliders, both in degrees and also in raw values. Yeah, that's pretty cool. I will do some other stuff, so let's see next videos. Okay, that's it, and thank you.